Hello, gorgy porgy children. Okay, so today I'm going to be telling you about multiplying and dividing numbers in index form. What do I mean when I say index form? So this would be if I said 4 to the power of 2. That little number there is the index, okay? And if we've got more than one, so that's an index. If we've got more than one, we call them indices. Okay, so that's the plural of it. And what it means is that it's 4 times 4, okay? A lot of time people will multiply 4 by 2, but it's not. It means that 4 has to appear in the sum 2 times, okay? So if it's 4 by 6, with a little 6 on the top, then it has to be 4 times 4 times 4 times 4. It has to go in 6 times. All right, let's move that up. Okay, so that's the first important thing that you have to know. If I say to you I wanted an index form, it will be, say, 4 to the power of 3. That's index form. That's the short form, okay? If I say I wanted an expanded form, so like you would expand a spring, you would go 4 times 4 times 4, okay? So you need to know the difference of those. And then if I said to you evaluate it, it means answer it. If I said to you, here is 4 times 4 times 4, and I want you to simplify it, that means shrink it back to 4 to the power of 3. If I said to you and then evaluate it, it means then I want you to answer it. So what is 4 to the power of 3? Okay. What else? Right. On your calculator, you can do this. Work out how it is on the green calculators. You've got to push the little up caret, and I'll show you how to do that. Because it really helps to make it much quicker, get through all this quicker, and get the correct answers, of course. Okay, the next thing I want to show you is if I had to say to you, let's just move these ones up. If I had to say to you, I've got 3 to the power of 7 times 3 to the power of 5. Okay. Your first question that you've got to ask yourself, and I even wrote this down in my notes, is, are the bases the same? Now, over here, this is the base, and that's the base. If the bases are the same, you keep the base. So your answer still has a 3 in it. Okay. So are the bases the same? If yes, keep the base. What do you do with these little numbers? You add them. Okay. So you keep your base the same and you add your indices. So 7 plus 5 is 11. You put 3 to the power of 11. And that's your answer. Okay. If I had to say to you this question, look here. 2 to the power of 3 times by 3 to the power of 5 times by 2 to the power of 4 times by 3 to the power of 6. Okay. Now, you know that you can use that 2 and that 2, and then you can use that 3 and that 3. They can go together. So let's answer it like that. Okay. So we've got 2 to the power of 3 and we've got 2 to the power of 4. We keep our base. We keep it as 2. We add our indices. So we've got a little 3 and we've got a little 4. 3 and 4 give you 7. Multiplied by, we're going to keep this base, keep that base. So we're going to keep that 3. And we're going to add the 5 to the 6, which gives us 3 to the power of 11. So what you've done there is you've simplified it. If the question says, and then evaluate, then what you're going to do, you're going to put into your calculator 2 to the power of 7 multiplied by 3 to the power of 11 and get your answer. But that hasn't asked you to do that. Another thing I want to bring to your attention is if you have 2, like you say you've got negative 2 to the power of 2. Now we know that they're very precious. We can't change it, so we have to go negative 2 times negative 2. Okay, so negative times negatives will give you a positive. All right. If we have a question that says negative 2 to the power of 3, so it's negative 2 times negative 2 times negative 2, oh, put a little negative in there, which means is negative times a negative gives you a positive. A positive times a negative gives you a negative. What I'm trying to show you here is if your indice is even, it creates a positive integer. Okay? If your indice is odd, it creates a negative integer. So when you've got heaps and heaps of numbers that you have to multiply, it gets quite confusing to go through it and say, plus that times that. But if you know you've got an even amount of numbers, you've got an even indice, you know you're going to get a positive return. And if you've got an odd one, you're going to get a negative. Okay, so negative numbers will give the even. Evens are positives and odds are negative. Okay, so that's what you've got to over here. All right, now let's do some more examples so let's look at this one. So we've got negative 3 to the power of 2 times negative 3 to the power of 3. Right, ask yourself the first question. Are the bases the same? If yes, okay, then keep the base. So we keep the base. Okay? Then we say add the indices. So 2 and 3 will give you 5. Put it in brackets. And then you'd have to, in this one it says evaluated, so you would put that in your calculator. Now, calculator even has brackets. And remember, if there are brackets, use them. Okay? You've got to use them. But what happens if you get a sum that looks like this? And it says negative 7 squared times by negative 4 to the power of 4. So your first question is, are the bases the same? No, they're not the same. If they're not the same, then you've got to find out what the answer of that is. And we'll put it in my calculator. It's negative 49. Because 7 times 7 is 49. And remember, we put it in brackets with a little negative in front of us. So negative's our answer. So it's negative 49. And then negative 4 times negative 4, well, we know that the answer is going to be what? Because it's a 4, we know the answer is going to be positive. And the answer is 256, because I put it in my calculator. And then you add those together. And in this one you would get, because you multiply them, you would get negative 12,544. Okay, so if they are not the same, then you've just got to work each little one out and put the answers underneath them and give you the final answer. So you say to yourself, are the bases the same? If yes, keep the base, add the indices. If no, work each one out themselves. Now, when you come to division of indices, it doesn't make it more complicated. There's just a few more things that you have to know. What you've got to do first of all is same thing. If they're the same, keep the base, subtract the indices. Okay. So if you have, where's my pen? 3 to the power of 9 divided by 3 to the power of 4. Are the bases the same? Yes. I keep the 3. I say 9 take 4 because now we're doing division. 9 take 4 would give me 5. 3 to the power of 5. Okay. Now, if we have something that's a little bit different, so the bases are not the same. So let's look at this example. We've got, in brackets, we've got 2 to the power of 11, make that 11 right, times by 5 to the power of 4, divided by 2 to the power of 9, times by 5 to the power of 3. Now, are the bases the same? No, they're not. Right. First thing you do is you make it into a fraction. So you go 2 to the power of 11 times by 5 to the power of 4 divided by 2 to the power of 9 times by 5 to the power of 3. Okay. Now, you've still got to subtract your indices from the same base. So can you see that there's a 2 here and a 2 here? 11 take 9. So, I'll put it next to it. We've got 2, so we keep our base. And we say 11 take 9 gives you the power of 2. Perfect. Multiplied by 5 and 5. And we've got, the indice is 4 and 3. So 4 take away 3, you're left with 1. Now you don't ever put a number 5 to the power of 1. You just put 5. We know that the 1 is there. So we put 5 there. And then, if it says, this one would just say simplify, but if it said evaluate, then you would work out 2 times 2 is 4, and you would times, and you would times that by 5, which would give you 20 as your final answer. So, if they're not the same, divide, put them as a fraction, and then work down. Remember that if you can't have 5 to the power of 1, it would just remain as 5. And that is it, my lovelies. Go ahead and give it a bash.